Good morning, everybody, and you're very welcome to another Signpost Series webinar. I suppose, on last week, it's been a tough week and a lot of people, a lot of damage done across the country, a lot of people without power for the week, and just apologies last week we pulled the webinar because there was so much devastation, a lot of ESB out, and I suppose we're just thinking of everybody out there that had a lot of damage done and hope everybody stayed safe and well there over the last week. And just to let people know, the webinar that we pulled last week was going to be with Lindsay Wistance. She was an organic research centre in the UK, and it was about agroforestry and its benefits for animal health and welfare. And that'll be put back to a later date. So not to worry, you'll get a chance to see that again if you're looking forward to that. But today we're discussing a different topic. We're looking at protected urea, emission reductions, performance and spreading conditions. Protected urea is vital for Ireland as it significantly reduces greenhouse gas emissions and ammonia emissions, supporting sustainable agriculture and environmental goals. There's been excellent uptake across farms in Ireland to date, and joining us today, we have a number of Teagasc experts just to give us an update of what's going on with protected urea. And we have a lot of good people in the room today, so just to encourage people to make sure you get plenty of questions in about protected urea. So look, today we're delighted to be joined by Mark Plunkett, Patrick Forrestal, Áine Murray, and Dermot Forristal. Good morning, everybody. How are you keeping? Mark,
Morning, Carl.
I think you're on first, and you're going to help me with questions today as well. But can you tell the audience a little bit about yourself and what you're up to?
Yes, good morning, Carl. Yes, my name is Mark Plunkett. I work with the Signpost program in the whole area of training and development, and I'm based at Johnstown Castle Research Centre.
Lovely. And
Uh, Yeah, look, I suppose, I'd just like to thank you and Yvonne for inviting us on here this morning. Carl, it's very, very timely. As you know, farmers sit down with their fertilizer plans and prepare for their fertilizer shopping list for 2025. It's very important, to select a cost-effective fertilizer and also a fertilizer that's going to, be easy on the environment. So, Carl, this morning, my talk is very much around why protected urea and why now.
lovely, Mark. Thanks a million. And Patrick, you're going to be up second. Can you tell us a bit about your role, I suppose, in Teagasc and what you're going to talk to us about today?
Hello, everyone. My name is Patrick Forrestal. I'm a researcher with Teagasc based at Johnstown Castle. And I suppose over the years, I've been doing a lot of work in the nutrient space, including protected urea. I suppose looking for solutions that can deliver on the agronomic front, but also help us to meet the commitments we have there to reduce emissions to the environment, be they through greenhouse gas emissions, leaching, or ammonia in particular. And today I'm going to just give a little bit of a summary of what we've seen in the trials with protected urea, including last year, which was a tough year, and looking forward to any questions that come along afterwards.
Yeah, unusual year last year, so it'll be great to get into that bit of discussion. And Anya, can you tell me a little about yourself and what you're going to present on today?
Yeah, so I'm a researcher based in Teagasc Moor Park, and I'm going to look at protected urea under grazing conditions. So I'm going to touch on what production was like on some of the research farms last year in terms of whole systems experiments, and also look at the performance of protected urea under grazing plot experiments as well on different research farms across the country.
Super on, yeah. A lot of people be interested to hear how grass growth went. And Dermot, finally, you're going to be bringing the home run, I suppose, at the end. So can you tell us a bit about yourself and what you're going to present on today?
Yeah, Carl. Yeah, I'm a researcher here based in Oak Park. I'm working on crops and mechanization. I suppose from the mechanization side, I'm here today. I have an interest in all things mechanization, but particularly in fertilizer spreading. And so spreading any fertilizer, getting it out evenly is always a bit of a challenge, particularly at wide aboutwidths, but urea does present an extra challenge. So I'll be dealing with that today. And myself and Francis Quigley, machinery specialist, are kind of looking into this area lately and dealing with that. So that's it for today, Carl.
That's super. Look, so Mark, you can start getting your slides ready there. And look, just to let everyone know, everybody on the four people are going to be presenting maybe about kind of 7 or 8 minutes each. And then we'll have maybe about 20 minutes for questions at the end. So don't forget to get your questions into the Q&A tab. Don't wait till the end. Just keep them coming the whole way through. And myself and Mark will try and get through as many as we can at the end. And just to remind everybody that this is going to be recorded as a podcast as well. So when you're on the move in the tractor or walking up, looking after your animals or grass measuring, you can have the podcast on and you can keep up to date at all times. So Mark, whenever you're ready, you can start off.
Okay, thanks, Carl. Good morning, everybody. This morning, I'm going to address the question, why protected urea and why now? So again, I suppose just to remind ourselves a little bit around climate change targets. Climate change is alive and well. Again, in terms of our national law, there's the Climate Action and Low Carbon Development Act, which came in 2021. This translates into the Climate Action Plan, which outlines a plan for each sector in terms of emission reductions. They range anywhere from 25% to 75%. Agriculture is one of the large emitters. We emit about 38% of GHGs here in Ireland, and our target for 2025 is a 25% reduction. That's done in two phases. We're currently in phase one, where there's a target of a 10% reduction. And just to put the numbers on it there, agriculture emits 21.3 megatons of CO2 equivalent, and our target, that's the baseline in 18, and our target emission reduction by 2030 is 17.25 megatons. In the Climate Action Plan, there's a number of technologies or measures in terms of how we're going to achieve that reduction. Just the ones which are most pertinent or important here this morning is fertilizer. So there's good news in terms of our chemical fertilizer usage. We have reduced by approximately 24% since 2018. We've come from 400,000 tonnes back down to 300,000 tonnes, and that's where we'd like to keep our nitrogen levels. I suppose the other big change there is the move to move 80 to 90% to replace CAN with inhibited or protected urea. Now, that's the next change that we require, and will be a big change, across the industry to move to more inhibited or protected urea products. In terms of where we are around the 25% target, so again, we're on track to meet that 10% emission reduction target. In 2023, agriculture reduced its emissions by 4.6%, and again, mainly driven by the reduction in chemical nitrogen usage and also the move to protected urea. To keep on track, the big, I suppose, challenge now is to keep that move to protected urea. In 2024, we need a 3.7% reduction for the sector, and in 2025, a 3.8% emission reduction to keep on track for our 2025 target. We're fortunate in agriculture. We're one of the only sectors that has a roadmap in terms of a technology toolbox. So there's 18 technologies in there. Anything below the line saves the farmer money. For example, EBI, liming, clover, multi-species. But one of the big technologies in there from a carbon emission reduction point of view is fertilizer formulation, as in protected urea. So again, the MAC, it's based on Irish research. Like there is, for example, protected urea, there is 15 years of research, and the MAC is supported by 16 pages of references from research done here in Ireland, and it can deliver up to 5 megatons in terms of carbon emission reduction. So again, if we take protected urea, it's one of the key technologies. It's vital for our sector, and again, when we make that switch to protected urea from CAN-based nitrogen, it's most effective in terms of reducing carbon emissions. Like we can reduce emissions by 71%, and it's like replacing a light bulb. And again, feeds into our emission reduction target for 2030. The other area is ammonia emissions, and again, going from ordinary urea to protected urea, we can reduce ammonia emissions by 78%. Currently, Ireland is in the EU courts in terms of in breach of ammonia emissions, and we face large fines to the tune of 8.2 million and further sanctions in terms of agriculture. Okay, if we look at what's the impact of protected urea on farm carbon emissions. So I have an example farm here, 50 hectares, 67 cows, a very productive farm in terms of milk solids, and a stocking rate of 1.9 livestock units per hectare. Where we go from CAN to protected urea, where we make that switch, it has a significant impact on total farm emissions. We can reduce emissions on this farm by 7.8%. And again, the typical emission reduction is 8%. So it's quite significant in terms of what it can do, and it's an instant reduction in carbon emissions that we can achieve. In terms of what will it mean for livestock numbers in terms of emissions? So again, if we take the same farm, again, by switching to protected urea, we can reduce total carbon emissions by 33.5 tons on this farm. Each cow produces approximately 5 tons of CO2 emissions. So on this farm, we can reduce the emission of 7 cows, or 10% of the herd. So if you think of your herd at home, how many cows do you have? Take 100 cows, so you can reduce the emissions by 10%, or 10 cows on that farm. The other big question is, as well, is, what is the impact in terms of fertilizer rate? So again, if we decide in the morning that we're going to stick with CAN, we're not going to move to protected urea, this technology is not for us. What effect will it have in terms of carbon emission, or in terms of the nitrogen rate? So in the farm example I have here, the nitrogen rate is approximately 210 kilos per hectare currently on protected urea. And if we decide to stick with CAN, again, to get that same emission reduction, we will have to reduce our nitrogen rate by 40%. So again, this will make this system unsustainable. We will not be able to grow the grass or the forage required to drive or feed this system. And also, if you looked at tons of fertilizer, so currently, you can apply 39 tons of CAN. And again, if we were to get this emission reduction, as we do with protected urea, we would have to go to 24 tons of CAN. So again, not enough nitrogen to feed the system, or look at alternative technologies there to supply that nitrogen in this farm example. Okay, if we bring it on then, so again, at this time of the year, a lot of us now are sitting down with our farm fertilizer plans. In this example here, you can see the total nitrogen is 17,500 kilos. There's 1,325 kilos of phosphorus and 2,555 kilos of potassium. So again, if we take an option one, if we stick with the traditional fertilizers, so if we go with something like 27,2.5 to meet our nitrogen and our P and K requirement, we need 53 ton. And then balance up, for nitrogen, we use CAN, 11 tons. You can see the total bill there is quite big, and there's 30,080 euro. If we go for the more sustainable option, again, sticking with the traditional 18612 in terms of supplying our NP and K, and switching to protected urea in terms of our straight nitrogen source, you can see the bill is quite smaller, quite an impact here. It's costing 26,370 euro. So on this farm, this is a real farm. Again, the total savings here is quite significant in terms of the fertilizer bill, and also in terms of meeting our sustainability credentials, the saving of 3,710 euro, or 36 euros per hectare. So in summary, Chairman, protected urea, it's a proven technology for Irish soils and Irish systems. It can deliver a big chunk of our emission reduction target come 2030. It can deliver approximately a third of the 25%. It's very easy to adopt. So when we're ordering fertilizer in 2025, choose the more sustainable options, as in protected urea or 18612. It's a big winner in terms of reducing the farm fertilizer bill and fertilizer costs, and it's a vital technology in terms of delivering low carbon or low emissions for the sector as we move forward. I suppose to date there has been much debate about and discussion around protected urea regarding grass growth and spreading, and this will be addressed by my colleagues in the next talk. So again, I will hand you now over to Patrick Forrestal.
Super, thanks a million, Mark. So Patrick, you can share away. Look, Mark, just in summary, I think this is low-hanging fruit for farmers. It seems like it goes a long way to trying to come at our 25% reduction by 2030, and it's a win-win, I'd say, for all by looks of your presentation. Okay, Patrick.
Very good. Thanks, Mark. So look, I suppose just to pick up from where Mark left off, I think just very briefly, it's good just to set out at the outset fertilizer forms. Right, it's a bit technical, but the fertilizers that we use here in Ireland are in very much the main containing urea, ammonium, or nitrate, or a combination of these in various forms. Mainly, of course, the granular solid fertilizers. But I suppose what I've found over my time in Teagasc is that every year I get asked more questions about liquid fertilizers of various sorts, and I'll touch on those towards the end. But mainly I'm going to focus on the solid fertilizers and the performance in the in the grass setting. So when Mark talked about the protection, what is this, and what does it do? So to speak a little bit on this point, there are a number of active ingredients there that we're in a position to recommend based on the weight of evidence that is there. So we're in a fortunate position that it's not just one active ingredient, and indeed not just one supplier. So NBPT, there's been an enormous amount of work done on NBPT urea here in Ireland. This is off patent, and there are quite a number of different suppliers. So Agritane, NitroShield, Glaze Extend, N-Protect. There are others, and this is growing because these are off patent. And there's a whole, I suppose, growing array of finished fertilizer products that are being produced with these various inhibitors. There's also NBPT plus NPPT. So this is the Limus product. And actually, as it stands, the highest number of blenders have chosen to use this particular option. We, I suppose, in the Irish context, think about these often as protection for solid fertilizers, but they're also available for liquid fertilizers, and indeed in other markets are used extensively with liquid fertilizers. There's also 2NPT, which is a product of SKW in Germany, and there has been some of this product also on the market here in Ireland. So what does the protection actually do? Mark mentioned that those ammonia emission fines that we're potentially facing. So it's not just the fines, but also from an efficacy point of view, for performance in the field, it's important that the urea is not losing some of its nitrogen away as ammonia gas, which is nitrogen. And the more ammonia loss that you have on a given farm, so examples of loss pathways for this are if a splash plate slurry spreader is used or standard urea is used, there's less N there staying on the farm to grow grass. And you can think about that ammonia loss as effectively it's eating into your N allowance to grow grass because that nitrogen is blowing away. So let's take a look at some of the trial results that we've seen over the past years, I suppose, to give some background information in the context of, I suppose, queries as to can the protected products stand up and perform as well as can. This is work from plot trials, but it's important to say that also we have been spreading these at farm scale for many years. So at Johnstown Castle, we were one of the first farms to go all protected urea, and we've been spreading on the farms with a disc spreader protected urea products for many years at high rates, at low rates, at silage rates, without issue. But there's no doubt that there was issues that out there last year, and Dermot will talk to that point in more detail. But in the plot trials where we can compare head to head a wide range of fertilizers at a wide range of rates in a replicated setting in a small area where you don't have, I suppose, differences in fields occurring, what we see is that for urea can and NBPT urea applied over 2 years at 3 sites during the season, we didn't see differences in their performance. And when we look at the overall yield in this work for the year, the NBPT urea matched the can yield across these sites. There was a trend for urea to have slightly lower yield, and this makes sense because it's losing some of its nitrogen away as ammonia gas. And this is why the protection is important. In 2017, my colleague Dominique Kroll conducted a trial where we looked at urea versus can versus NBPT urea versus NBPT plus NPPT urea. So that's the Limus. The 0N plot grew 4.5 tons. The urea grew just over 10 tons. And if we look now, how did can perform in comparison to the standard urea? Well, it grew an extra 833 kilograms per hectare. So here we have a setting where can is doing better than urea. So did the protected product stand up? Yes, the NBPT grew an extra 1.5 tons over and above the standard urea, and the NBPT plus NPPT urea grew just under 1 ton extra versus the standard urea. Come to 2024, a very challenging year on many farms with a wet spring and then dry periods and extended dry periods during the summer. At Johnstown Castle, we have a head-to-head fertilizer trial comparing urea to CAN to NBPT urea to NBPT plus NPPT urea and 2-NPT urea. Okay, so just get familiar with these, I suppose, active ingredients and these terms. And what we saw in the spring, so we were delayed getting into harvest because the site was wet. You can see here are the results at each cutting for the different fertilizers. So come on here to May. This first bar is the control, 0N. The second one is CAN. So you can look across here, across the year, with the second bar being CAN as your reference, and then the rest being the various protected urea products. How do they perform over the course of the season? And what we saw was that they gave similar yield to CAN as we went through the season. There was definitely a number of cuts during the summer where yields were very disappointing, but there was no, if you like, magic fertilizer that was able to overcome that reduction in yield that we saw as we went over the summer. If the protected urea yields were back, the CAN yield was back also. When we bring that together for the whole season, let's see how it all shook out. The 0N grew just 2.5 tons. The standard urea grew just under 8 tons. CAN gave an extra 199 kilograms of yield over urea. The NBPT urea, 130 kilograms. The NBPT plus NPPT urea, 264. And the 2-NPT urea, just around 400 kilograms per hectare. So what we saw last year in these head-to-head trials with the fertilizer applied at the same time, at the same rate, and cut at the same time, very similar performance from the fertilizers and the protected urea products keeping up with the CAN. So I always like to touch a little bit on what's new, and I mentioned the liquids. We have a Department of Agriculture funded project at the moment, and just to give a little sneak preview of some of the results we're seeing there. Comparing to CAN, the urea fertilizers, and this includes protected urea fertilizers, are giving lower emissions, and this is the greenhouse gas picture, but also some liquid fertilizers like this Flex-N and UAN giving low nitrous oxide emissions. So there is potential there for the future. We're also seeing that nitrification inhibitors, and this is a term I suppose that you may come across as time goes on, nitrification inhibitors also getting emissions down even further, close to background levels. We're seeing some yield benefits. And for this Flex-N product, it was giving similarly low ammonia emissions to NBPT plus NPPT urea. So just to finish up, the technology that we have there is these protected urea products. As Mark has indicated, it's very important for the sector for delivering on our emission reduction commitments. So if you use them or stick with them, this will help to reduce your farm emissions and emissions of the sector overall. And I do want to mention, just as a part, take a look at this picture. This is the difference with adding sulfur versus not adding sulfur. So including a few rounds of a sulfur containing farm on your, including a few rounds of a sulfur containing fertilizer on your farm can be important for getting the most out of the fertilizer that you have applied. We're seeing yield and also nitrate leaching reduction benefits, and of course water quality is a very important parameter for us at the moment as well. And just to acknowledge all the colleagues and collaborators and the funding that we received for this work. And Áine is going to, I suppose, take us forward into the grazing studies now.
Super. Thanks a million, Patrick. And Áine, you can put up your presentation. That was brilliant, Patrick. And just to remind everybody, the questions are starting to roll in there. You won't get a better chance to have as many people that specialize in the area in one room at one time. So make sure to keep those questions coming in. Okay, Áine, thanks a million.
Yeah, so I just firstly wanted to touch on that in the Moore Park Systems experiment, and we have been using protected urea as the main nitrogen source, or all the straight nitrogen has come from protected urea products. And particularly in different parts of the country for 2024, we saw a massive reduction in herbage production, and that Moore Park site did suffer from drought for most of the main growing season, and we saw a big reduction in our cumulative grass grown compared to our 5-year average. So both the grass only and the grass clover areas saw this reduction. We saw only 12 tonne grown on the grass only compared to the 5-year average of 13.5 tonne, and an 11.5 tonnes grown on the grass clover area receiving 150 kilograms of nitrogen per hectare compared to 13.8 tonnes at a clover content at 20.6%. Compared to other Teagasc farms that are also using all protected urea, such as Clonakilty, we saw that they didn't really suffer from drought last year in 2024, and their production, herbage production, was maintained for 2024 compared to their 5-year average. So similarly, their grass only area receiving 225 kilograms of nitrogen per hectare grew 15.7 tonnes versus their 5-year average of 15 tonnes. And their grass clover, 150 kilograms of nitrogen per hectare farmlet, grew 15 tonnes at 16.1% clover content compared to 14.3 tonnes for their 5-year average. And we saw that across Ireland that pasture production on average did reduce just about a tonne on farms measuring on pasture-based Ireland compared to the 5-year average. So there was large variabilities in herbage production depending for 2024, depending on different areas in the country. Within the systems experiment here in Moore Park, we do measure mineralisation and fixation. So we do have mineralisation plots or zero nitrogen plots. They're 5 by 5 metre plots. They don't receive any organic or chemical nitrogen source for the year and are moved within paddocks between years. So they're not grazed and they're harvested every rotation the same as the paddocks are. And they are yielded and the nitrogen content is measured. So we see from the 3-year average here that the grass only zero nitrogen plots consistently for those 3 years had a total herbage harvest of 7.6 tonnes and a nitrogen yield of 185 kilograms of nitrogen per hectare. So that nitrogen yield would be coming from mineralisation from the soil organic matter content of the soil, whereas the grass clover ones grew 10.1 tonnes and had a total nitrogen yield of 284 kilograms of nitrogen. So that would be from mineralisation and fixation, which would assume about 99 kilos of nitrogen being fixed. Compared to last year, there was a big reduction on these zero nitrogen plots for 2024. We saw that 1.5 tonnes that was reduced on the platform was directly reduced in the mineralisation plots. So for last year, they only yielded 6 tonnes and 160 kilos of nitrogen per hectare, and the grass clover ones yielded 7.2 tonnes and 222 kilograms of nitrogen per hectare. So there was a reduction in mineralisation and fixation on that Moore Park site for last year, and this is how it looked in terms of those rotations across the year. So there was big reductions for June and July, and in terms of clover, it only really recovered from August onwards, whereas we would see normally in previous years that they would have had a very high a much higher yield compared to the grass only from May onwards. So that's what's happening in the systems experiments and on farms. When we look previously at the direct comparison between fertilizer types from an experiment from 2019 to 2021, I looked at grazing plot experiments on the Moore Park farm, Clonakilty, Ballyhaise and Athenry, comparing CAN versus standard urea versus urea protected with that NBPT product. We compared it at 2 different fertilizer rates, 150 and 250 kilograms of nitrogen per hectare, and the 150 and 250, the 150 rate was spread at 0.6 of the 250 at each application. Plots were grazed at 1500 of a cover, and the nitrogen was applied after each grazing event. So when the plots were grazed, the nitrogen went out in the next few days. And just originally in 2019, we had the Moorpark and Clonakilty site, and the Ballyhaise and Athenry were added as new sites in 2020. So this has been published in the Journal of Ag Science, and across all the sites and all the years, we saw no effect of fertilizer type in terms of CAN and the protected urea product, but there was an effect in terms of the standard urea. It was slightly less than the other two. But there was no difference between CAN and the urea plus NBPT product at the 150 or 250 kilograms of nitrogen per hectare rate. We also did look, because it was such a big data set, we did compare any dry rotation with over those 10 site years. So we defined a dry rotation as any spell of weather that had 10 consecutive days with no rain, had an average temperature of over 18 degrees Celsius, and a soil moisture deficit was occurring. And we had 14 rotations across all the rotations that qualified for this criteria. And we saw during these rotations, there was no effect of fertilizer type at any of the rates in terms of pre-grazing yield. So they all yielded the same, even during those dry weather conditions. Afterwards, Brian McCarthy and Megan Bock continued on these comparing CAN and urea plus NBPT under grazing plots in Moorpark and Clonakilty. So they still had the two fertilizer types, and they changed the rates to 120 and 200 kilograms of nitrogen per hectare. And then just for 2024, I said we are presenting the results for 2024 as that's the year people are most interested in now. They saw no difference in terms of CAN and urea plus NPPT at the two rates in terms of pre-grazing yield or cumulative yield across the year. And this is how the pre-grazing yields looked in terms of rotations for 2024. There was no difference in fertilizer type, with CAN being the dark green and urea plus NBPT being the light green in terms of difference in pre-grazing yield. So to summarize then, urea plus NBPT works just as well as CAN across multiple experiments, years and sites under grazing plots. Even under the dry conditions, we did not see any difference between urea plus NBPT and CAN in terms of pre-grazing yields. And Teagasc are going to continue monitoring the performance of urea plus NBPT versus CAN going forward. And these are going to be communicated regularly to farmers and stakeholders.
That's super. Thanks a million, Áine. And maybe Dermot, if you want to get your presentation ready.
Yep.
It's brilliant. Just remind everybody the Q&A is there. There's plenty of good questions coming in, so we'll have a great discussion after Dermot's finished. So Dermot is the last speaker for today. Thank you, Dermot.
Thanks, Cathal. Yeah, look, I'm moving on to the last part, which is whether we can spread this urea evenly or not. Okay, so just to my slide moving. Yeah, so just to say that urea is different, right? It's different physically, and because of that, it throws or broadcasts differently. And this can sometimes mean that we have to work with our maximum bout width that a fertilizer spreader could achieve might be less. But it does always mean really that you need different machine settings to make sure that this fertilizer will spread evenly. But given that, we still can, spread urea evenly, provided the physical quality is okay. So the factors that impact on this evenness are the fertilizer physical quality itself, the fertilizer machine design, the machine setting, And then finally, of course, field conditions like wind. So to deal firstly with the fertilizer, like what characteristics are important? Well, these are granule size, the size of granules, and that will affect the distance to which the fertilizer will throw on a broadcast spreader. Density will also affect the distance and the susceptibility to wind. The shape of the granule will affect the distance to some extent, but also the trajectory. But very importantly, the granule strength is hugely important, because if we have weak granules, they will tend to break during handling and certainly break on the fertilizer and it's on the spreader, and it's impossible to spread dust. So our message here for all is to source fertilizer with good physical quality. It's hugely important, and we need to value that. To deal specifically with urea and the physical characteristics of urea, the one thing that's different with urea, it has a lower bulk density. So typically it's about 0.8 of a kilo per litre versus other fertilizer products being somewhere in the region of 1 kilo to 1.3 kilos. So in the extreme, you can compare this density effect to be something like comparing a table tennis ball with a golf ball. They both might be the same size, but you're going to throw a golf ball much further and with much more accuracy than you will a table tennis ball because of the difference in density. So density affects the distance to which you can throw and the sensitivity to wind. Other important areas in terms of physical characteristics are the particle size distribution. And with all fertilizers, we'd like to see 90% of the particles greater than 2 millimeter, with a good proportion of those greater than 3.3 millimeters. Particle strength is also important. And again, we'd like to see an absolute minimum with urea, I suppose, of about 3 kilos at the point of spreading or at the time of spreading. But you'd preferably like to see particle strengths being greater than 5 kilos. That's the crush strength. Also, just to say that physical quality can change. Just because a fertilizer starts off with a particular quality, the way it's stored and the way it's handling can have a negative effect, if you like, or on the physical quality over time. Just to show you this area of size distribution, two urea products here. The first slide shows one here. You can see there's 4 different categories of particle sizes: less than 2 millimeters, 2 to 3.3, 3.3 to 4.75, and greater than 4.75 here. And this particular product meets the criteria of having 90% over 2 mil. But just look at the shape, how much is in each of those categories, right? Whereas if we move on to another product like this one, again, it meets the 90% criteria, but much greater proportion of this is larger again than the 2 millimeter size. It's in the 3.3 to 4.75 millimeter category. This would be easier to throw properly, but both of these fertilizers would be, it's possible to spread them evenly. Some of the problems, though, that arose in 2024, there were some extreme problems with urea. Spreading urea, and it was protected urea that people were using at the time, but this is associated with poor particle strength. Okay, so my colleague Francis Quigley would have looked at some of these along with Mark Plunkett there, and they were measuring crush strengths of the particles of less than 2 kilos, which is very, very poor particle strength. So that means the product was breaking to dust before and during spreading. Okay, once it hits the veins, it was breaking, and this makes it impossible really to spread evenly, even with fairly narrow bout widths. And it was compounded then by the caking on the veins. What you're looking at in that bottom picture there is a vein with urea caked into it. But this only affected some batches, but those batches were badly affected at the time. So there were problems in 2024 with that. So to move on from physical quality of the fertilizer, which is hugely important, to talk a little bit about the machine, the fertilizer spreader itself. Well, the important thing is to use a good spreader with any product, but particularly for urea, because the density makes it a little bit more of a challenge. And what I mean by a good spreader is a good basic spread pattern, right? And that means really a triangular shape, so that if you looked at the shape here, if you look at on this diagram here, the 2 black lines in the center simulate the middle of the tractor, if you like, going along a tram line or about width, if you like. And the solid blue is the distribution of fertilizer to each side of the tractor. In other words, it's at its highest behind the tractor, it tapers off to each side. But then that overlaps the next bout and the next bout. And they actually, by overlapping, will result in a spread evenness, which is indicated by the red line in the graph. And we can measure that evenness by expressing it as a coefficient of variation. In this case, that coefficient of variation is 6.7%. So that's quite good. So what we really need when buying spreaders is to have information that will tell us that it can spread urea at the desired bout width, whether that's 12, 15, 18, 24 meters, that you need to know that you'll spread at a relatively low CV. In practice, that might be something like less than 7% in a test hall test, something like that. So that's the target. And just to say at this point, the GPS type technology, which is a great boon when you're spreading fertilizer for getting to turn on and off points accurate, it has no real role in spreading evenness at all. So just because a fertilizer spreader has GPS technology on it will not necessarily mean that it spreads well. What we need is that good basic spread pattern. Once we have that, then setting the spreader is absolutely hugely important. And people have gone along for years without ever changing a setting on a spreader for evenness. If they're changing from a conventional dense fertilizer product to a urea product, they need to change the settings for evenness. And this is usually settings around veins on the discs, maybe around the drop point fertilizer on the discs, maybe the angle of the hopper. It depends on the fertilizer spreader what you do. I'm not going to go into all of that today, but just to say that each spreader has its own unique way. So how do we know how to change that? Well, the scene has changed dramatically in the last 20 years. All of the major spreader manufacturers have quite advanced test halls. And in these test halls, they accurately measure the spread pattern of the spreader. And they go through huge numbers of fertilizers each year, testing fertilizers. Many of these Irish fertilizers, many of them not, but they create a massive database then of fertilizers and their spread patterns and the associated settings. And what we need to do then is to match the fertilizer that we're spreading, in this case, the urea products, the specific urea products, to what they have in their database, and that will give us the actual setting of the spreader. That's all done online or more commonly through a phone app at this stage. But what is important is that if it's needed, that a sample that the fertilizer manufacturer, for every batch of fertilizer they make or every season or change in batches, they send a small sample to the spreader manufacturer. And that small sample will allow them match it to a database. Some will go further than that. They'll allow us to do it ourselves by doing some simple tests and inserting that data in an app. So that's what we can see here. In this case, you can do a simple sieve box test, a particle strength test, and to identify the shape of the particles by matching them to a picture. Collect that information and then go to whichever spreader manufacturer that requires that information for their spreader, input that information to the boxes. There's only 4 pieces of data here, or 5 pieces of data that go in here. Select the shape of the granules and it'll give you an output. This is an output from a different manufacturer. It tells you the set of veins you should be using with that particular fertilizer, and more importantly, the width setting, the actual setting or adjustment of the spreader to achieve that. So this is vitally important to do this with urea. It won't be the same setting as with CAN or with a different type of blend. We can check the evenness by using tray tests. The use of a full line of trays in the field is not going to be feasible. It's hugely time consuming, but most manufacturers will give you a way of checking your spreader by putting out about, spreader or a set of trays in maybe 4 or 5 positions across the spread width. And that will give you an indication that the spreader is set properly, like in the second picture here on this particular slide. Okay. Finally, though, I'd say 2 other things really. Urea blends. This really is an additional challenge, because if you make a blend, an NPK product or an NK product with urea as the nitrogen source, you're dealing with very different densities. You have a density maybe of 1.3 kilos from the K source down to 0.75 for the urea. So there's a huge risk that even if you're spread it evenly in terms of the same amount of weight going on each square meter of the field, that you get a segregated spread pattern. In other words, the dense product will throw further. You get the urea largely behind the tractor, the K product in between the bouts. So that's a big, big challenge. So we would say stick with non-urea blends, right, with your P and K, and use urea on its own, unless the fertilizer supplier is going to provide test hall information for their specific blend with your specific spreader to show that it can be set to spread that blend. Some spreaders will do it at certain bout widths, but you need that information before considering doing that. So I'm going back a lot towards the physical quality of the fertilizer because there are have been some issues, I suppose, with that. It is different, but there are also some issues where the crush strength and so on has been poorer, and that needs to be improved. So can we improve it? The most important thing is that there's awareness among all fertilizer manufacturers, advisors, farmers about the importance of this. Voluntary standards would be useful, in particular in terms of having size distribution, agreement, what we should be going for. And there is some of that there in the industry, but particle strength needs to be part of that there's an agreed particle strength that's deemed to be acceptable or not. And what would really help, and we're in discussions, I suppose, about this, but what would really help is if the fertilizer physical quality was stated on the bags or batches of fertilizer that farmers are buying. That would really help if you had the particle size distribution, density, strength, and a date and batch number actually printed on that, because it would bring a whole awareness of physical quality and the value, because we need to value that physical quality when we're purchasing. So good sourcing, storage, and handling of fertilizer is important. And as I said, physical quality has a value, as does good spreading, and we need to be conscious of that. So to answer the original question, can we spread urea evenly? I would say yes, provided we have a product with good physical quality. That's hugely important. We need a spreader with test results for urea at the desired bout width. We need a database of spread tests and settings that's easily accessible, and it is with most spreaders now quite accessible. We need to select a bout and settings carefully, and you do need to avoid windy conditions because the product is that bit lighter. Avoid urea blends unless there are test results available, and apply the same standards if you're using contracting services. If you as a farmer are employing a contractor to do it, make sure the contractor is doing it right and reward him if he is doing it right. So this needs inputs from all, from the fertilizer industry, spreader manufacturers, advisors, contractors and farmers to ensure that spreading is optimized. So I leave it at that, Cathal.
That's super, Dermot. Thank you so much. Excellent, four excellent presentations. Covered a lot of ground there. And maybe if everyone turns on their cameras there and unmutes themselves, a lot of good questions coming in, and we're going to get through as many as we can. There's loads of really comprehensive questions, actual practical questions, and some heavier scientific questions. So we'll try and distribute them as much as possible. But Mark, I know you're going to help me with questions, so I'm going to start with one for you from your presentation. How important is protected urea in achieving our emissions in agriculture? Because we know the targets are high, we're doing quite well, but how important is it as a tool?
Yeah, I suppose as a technology, Cathal, it's quite effective. Like as I say, on a dairy farm, you can reduce total farm emissions by 8%. Taking a dry stock farm, it's probably about 4%. So it's a very significant technology. You know what I mean? And it's, as I said, it's you hit the switch, you switch from can to protected urea, you get that emission reduction target. So it's on total farm emissions. Maybe I said it in terms of the big figure, the 25% production, but it's on a dairy farm you're talking 8% of total farm emissions. So a very significant technology. In terms of the toolbox, like as I said, there's 18 technologies there. So we're encouraging farmers to pick out 2 or 3 of the tools along with protected urea. It could be soil fertility, low emission, clover multi-species swards to get on the road as regards reducing farm emissions. So there's plenty of options and technologies there.
Yeah, and I know it's been around for a while, and talking to Patrick before that it's been used not just in Ireland and many countries, but Mark, Ireland is not the same as other countries. How suitable is it to our soils and climate?
Yeah, like it fits very well for our soils. Our soils tend to be heavy, high in organic matter. They tend to be wet. The main pathway of nitrogen loss is denitrification, producing nitrous oxide, which is a very powerful greenhouse gas. So as I say, protected urea works very, very well in that setting or in that climate or in those soils. So that's why it's such an important technology to reduce nitrous oxide, a powerful greenhouse gas.
Super. Look, we've loads of questions, Mark. Maybe you throw a few out there to and maybe direct them at different people if you can.
Okay, I suppose one of the first ones there, maybe I'll go towards Patrick there. Patrick, is 18612 a good way to get sulfur out in terms of a fertilizer program?
Yeah, it can be, and I mentioned there the importance of getting a few rounds of sulfur onto the grazing platform, and I suppose I use the term a few because there's not really one size fits all for the grazing platform. I suppose as a rule of thumb, typically, let's say lighter, more free draining soils might need a few extra rounds of sulfur in there, and maybe a heavier, more poorly drained soil may not need as much sulfur. So I suppose if 18-6-12 fits in the timing of your fertilizer plan to deliver, for instance, phosphorus early in the spring to get growth going, and you're getting around the sulfur in there, maybe that ticks off one of the sulfur boxes. But maybe after that, depending on your soil fertility, perhaps you don't have a place for 18-6-12 again in the rotation. So I suppose look to use a sulfur containing maybe a straight nitrogen product or two, depending on the type of soil that you have. And I'd encourage people to kind of, I suppose, test this out a little bit on their farms. But one place that we do know that sulfur is really important is in the silage ground, because there's that high level of offtake, and most soils are needing a sulfur application there. And again, 18-6-12 could be a fit depending on what's your program for that silage ground and whether it's getting slurry or not.
Okay, very good. Question here for Áine. Are the grass plots getting chemical P and K, and would you know how much, Áine?
Yeah, we did spread 0, 10, 20 on the plots so that it was spread across them so that they all got P and K and they all got equal amounts. I think it was half a bag is what they got each year in one application. And yeah, and then they were getting recycling from the animals as well. So, but they did get a chemical application.
Okay, very good. Thank you. A question for Dermot. Dermot, a question here around blends and the urea and sulfur, and in terms of even spreading.
Yeah. Look, urea and sulfur would be quite a common blend. You know, you'd often get 38% sulfur or 38% nitrogen or 40% nitrogen with a sulfur component. And they would tend to segregate a little bit. But what I would say is they're probably not as bad as NK blends, in the sense that if the product is set for the urea, okay, the sulfur might not be perfectly evenly spread. In other words, there might be a little bit of overspreading with that. So, but the financial loss from that would not be as big as if you were doing the same with a K or maybe in the future with a P part mixed with it. So I'd be less concerned with NS blends than I would with NK blends. But physically, the same thing does happen. So that if you're at wider bout widths in particular, there's slightly different patterns from the urea part than there will be from the sulfur containing part. But I'd be less concerned as long as there's at least enough sulfur going out to kind of cover for that situation.
Okay, that's super. Okay, Patrick, a question here. What's the composition of Flex N?
Yeah, the Flex N is a liquid nitrogen product, a 24N and 3S. It's I suppose ultimately an amide or urea based nitrogen, so there's very little nitrate in it, and I think that this is an important factor in why we're seeing lower nitrous oxide emissions with it. It's also acidified, which is, I think, the avenue through which we're seeing those lower ammonia emissions with it. In a sense, it's using a different mechanism to protect it from loss. And we also saw good yield performance with it as well. So I suppose it's just to flag that we are all the time looking for new solutions in this space while trying to support the tools that we already have, which are important.
Okay, very good. Thank you, Patrick. Áine, a question here around biological nitrogen fixation. How is that? How did you measure that in the trial?
Yes, so for the results I presented, it's just simply we took the yield of nitrogen from the plots with the clover versus the grass-only plots, so it was by difference, and that's how we got the measurement. But we have other measures done through 15N analysis also on them, which stack up with the difference method also.
Okay, very good. Okay, another question here, Dermot. Does the slope of the ground affect the evenness of spread?
Yes and no. What's much more important is the relationship of the spreader to that slope. In other words, if the spreader is evenly set behind the tractor, the actual slope shouldn't make too much difference. But if you're going across bumpy ground, and the spreader lies into the slope or something like that, it is going to affect the pattern to some extent. So the slope per se shouldn't be a huge issue, the spreader, but keeping the spreader at right angles or perpendicular to that slope, that's what's more important.
Okay, Cathal.
Yeah, just on that, Dermot. There's a real practical question here, and it jumped to my head when you were talking as well. When you're talking about the fertilizer quality, there's a lot of farmers just commenting here that they're going to be buying fertilizer shortly. And how does the farmer know what the quality of that product is like? How can they, how can they
Yeah.
tell?
Yeah, look, it's difficult, but I mean, physically checking it out is the thing to do. Those simple test kits that we're talking about, or that you saw there in the picture, there was a crush strength meter there, and there was a granular sieve box. They're not expensive. Many of the spreader manufacturers will supply them free. So that's what you should use. In other words, you take a sample of your fertilizer, try to be a representative sample. That'll tell you your size distribution, and it'll also tell you your particle strength. It'll show you if you have dust in it already. It'll tell you your particle strength beyond that. Density, you can't do anything with. So, you can't, if you're dealing with urea, you're dealing with a slightly less dense product, but you just need to take that into account when you're setting it and spreading it. So you can't do anything with that if you have a urea-based product. That's more or less fixed. But the other things, I mean, I think it would be great if farmers did arm themselves with that equipment and did say, look, I want good physical quality. The supplier will probably ask you, well, what do you mean? Well, I mean, 90% above 2 millimeters and preferably more above that, no dust in the sample and a good crush strength. And actually be there and aware and have the supplier aware, Jesus, these guys are looking for this now. That's why I was saying to be great if we had a voluntary initiative where the information was printed on the bag as well, so which would further help it improve quality as we go along.
Yeah, good advice. And Patrick, there's a number of questions here around shelf life of protected urea. Even a few comments. Should there be a kind of a date on it, or if I buy the product last year, will it be okay next year? Maybe you can comment on that.
Yes, yeah, I suppose this is a question that's been recurring over the last decade. Look, there's a few things that are important to note. In the trials that we've done, we typically get the fertilizer at the beginning of the year, and we use the same fertilizer throughout the season. And that's the case in the results that I showed you. So in that sense, the test is, if you like, a little bit unsympathetic to protected urea, as in we're not getting fresh product for each application as the season goes on. An important factor, I suppose, for the shelf life and for the efficacy aspect is, how much goes on at the start, and that goes on uniformly. That's the starting point. And after that, there will be degradation over time, and that degradation is slowest in the N-only containing products, so they tend to have the longest shelf life. But most of the suppliers, they do have the technical backup and lab studies behind the products. So if you ask that question, you should be able to get, I suppose, information around how much inhibitor was put on in the first place. I suppose the voluntary standard that Dermot mentioned around dates of bagging and batch numbers, etc., statement of the inhibitor that's used and how much inhibitor was put on there in the first place gives the starting point for a product. But I suppose for a product that it has enough on initially and is put on nice and uniformly, there shouldn't be any issues with using that over the course of the Irish growing season. Because the other factor that they struggle with in much warmer climates is that the degradation is accelerated during very hot conditions. So if the product is stored at 30, 35, 40 degrees, which is an issue in other climates, but our climate, it's very rare for us to see those type of temperatures. So that is a help. Unless you go on holidays, maybe you might see those temperatures. Yeah. Alrighty. Yeah.
I know we're running up to time nearly now, Mark, but I'm going to run an extra 5 minutes. So there's a lot of questions coming in, so I want to try and get through them.
Yeah, there's a question there on spreading rates, maybe for Dermot there, where there's higher rates, say, on silage ground, what advice can you give, Dermot?
In what way, Mark? Sorry, what
I
do you mean
suppose, where you have higher rates, say, on silage ground, you know what I mean, in terms of splitting, or is there a benefit, like, or what would your advice be?
Well, from the spreading perspective, I don't think higher rates in terms of a urea product will cause any problems at all.
Okay.
So I think from a spreading perspective, that's not a problem at all. The only thing that I would say to people to watch, if they are going out in conditions that aren't perfect, like what you do have on grassland farms is you have the option of reducing your bout width. So if you're at a 24-meter spreading, say with a can product or something like that, and you're not too happy with wind conditions, even if the spreader manufacturer gives you the settings for 24 for urea, there's nothing to stop you stepping down to 18 and getting a setting for that, and 15 or whatever it is. The amount of work, your work rate impact will be relatively small if it gives you more assurance that in this imperfect day wind-wise, that your urea will spread better, because you'll always have less risk with a low density product with a narrower bout width.
Okay.
So
Yeah, go on.
another question here coming in around, is protected urea slower to release than can? And just looking at your research, that doesn't add up as regards grass growth.
No, we didn't see any difference. Like they were spread rotationally and they're spread on the systems experiment. They'll be spread every week, and we don't see any delay in response to the protected urea versus canned products. It's maybe Patrick's able to explain it as well, that like when it is spread, like the protection, it's on when it goes into the soil, and then it's used by the plant the same as other fertilizers.
Yeah, and I suppose the point being is you're growing grass over a rotation, you're not growing grass in the space of a week. Patrick,
Yeah.
just second part of that question, I think some research came out in this lately. Does protected urea have any specific consequence on soil microbes?
I suppose with my colleague Fiona Brennan, our soil microbiologist, we took samples from sites where we were applying these products over the long term, and that work is also published, so that's available, and we didn't see those effects. No.
Okay, Mark, any more coming in there?
Okay, yeah, there's a question there, Patrick. In the long-term nitrogen trial from Johnstown last year, why was the February cut higher? At that February cut, why was that higher? Or sorry, is it the April cut was higher, Patrick? From the February application of nitrogen.
Yeah, I think the first cut did there was two protected products there that produced a higher level of yield, and I suppose probably what you're seeing there reflected is, well, I suppose in the first place, right, we had a very wet spring, right? Okay.
Yeah. So
it was very wet conditions, and CAN was also applied. CAN contains half of its nitrogen as nitrate, which is a challenge for the greenhouse gas side of the picture. But also, if that CAN is sitting there in wet leaching conditions, a portion of the nitrate in it is susceptible to leaching, whereas a urea product is going to be in the ammonium form. And this is why I had the first slide with different forms, but the ammonium form is less vulnerable to leaching. So that this could be part of the picture, that more nitrogen just stayed there in the urea fertilizers, and a couple of the protected products were ahead. So it may have been that at the time that we applied that there was also some volatilization loss, and that the standard urea suffered, but that two of those products were essentially protected for. So you've got leaching and ammonia emissions coming into the picture in that case, which wouldn't necessarily have been a factor later on, particularly the leaching aspect.
Okay.
Unfortunately, I think that's all we have time for today, Mark. I think an awful lot of questions was coming through, and apologies to people that we haven't got time to answer questions for. It's great to see that there's so much interest in it, and it just means I think we're going to have to come back to this topic again. So thanks a million to everyone for that. I just want to thank Patrick, Dermot, Áine, Mark for really comprehensive, interesting presentations, filled a lot of gaps, answered a lot of questions. So I think that was really needed for the start of the year when people are looking at buying fertilizer coming up. Mark, big thank you to you for helping me out with the questions. And also Yvonne in the background. Yvonne is working away. She pulls all the cogs and gears in the background, making sure that everything runs smoothly, and this webinar is always run well. So thanks a million, Yvonne, in the background. look, next week we can look forward to a chat with Teagasc Asset Advisor Fiona Doolan, and Fiona's going to be discussing spring nutrient use, reduce losses and improve returns, and that's not to be missed. So do tune in again next Friday at 9:30. But until then, I hope you have a great weekend and slán go fóill.